So here's your final remediation on solving and graphing quadratic equations. So the first problem, we're going to solve x squared equals negative x plus 30. So if we rewrite this, we're going to have x squared, and we want to get everything on the same side. So plus x minus 30 equals 0. So with this quadratic, we want to factor. The goal is to find two numbers that multiply together to be negative 30, that add together to be a positive 1. So two numbers that multiply together to be a negative 30 would be negative 6, positive 5, positive 6, negative 5. We could have negative 30, positive 1. We could also have a positive 30, a negative 1. And out of these choices right here, and there are a couple of other ones, negative 15, positive 2, positive 15, and negative 2, but out of these choices, which one of these would give us a positive 1 combination, and that is a positive 6 and a negative 5. So that would be C. And how would I check this problem? I would distribute these back and see if I get my original problem, x squared plus x minus 30. To solve x, the quantity x plus 3 squared equals 36, I could do a couple of things. First of all, I want to subtract 36 over here to the left side because I always want my quadratic to equal 0. So the question is, what value here do I put in when I subtract 36? Do I get 0? So if I put 3 in here, 3 plus 3 is 6 squared minus 36 equals 0. 3 plus 3, 6 squared is 36 minus 36 equals 0. Well, that works. Let's try 9. 9 plus 3 is 12. 12 squared is 144. That doesn't work. So I know D doesn't work and I know B doesn't work. What about negative 9? Negative 9 plus 3 is a negative 6. Negative 6 squared is 36. So that also works. Okay. For this problem, 2x squared minus 4x minus 3 equals 0. We first want to think about quadratics and think that maybe we could factor. So you could try factoring, but because these are multiple choice and when I look at the answers to this, I don't see any factoring going on here. So what I want to think of is this looks like the quadratic formula. And to review the quadratic formula, it's the opposite of b plus or minus square root b squared minus 4ac all over 2a. And remember, in a quadratic, it's ax squared, or plus bx plus c equals 0. So I've got to take these components right here and put them into my quadratic formula. So the opposite of b in my equation right here is negative 4. So the opposite of b, so the opposite of a negative 4 is a positive 4. Plus or minus the square root of b squared, and we said that is a negative 4 squared, minus 4 times a times c. Well, a is 2 and c is a negative 3. So 4 times a is 8 times negative 3. So 8 times negative 3 is negative 24. All over 2 times a. So 2 times 2. So we have 4 plus or minus the square root. Negative 4 squared is 16. A negative times a negative is plus 24 over 4. Kind of running out of room. I apologize about that. So 4 plus or minus 16 plus 24 is 40. So 4 plus or minus square root of 40 over 4. Now my 4's out here are going to simplify, and inside here I can simplify 4 and 40, and I can break that down because the square root of 4 is a perfect square, so I can break that down, and this is perfect. And what is the square root of 4? It's 2. And so now these all have something in common. The 4, the 2, and the 4 all have something in common, and that is a 2, so I can reduce all of that by 2. So this becomes a 2 plus or minus square root of 10 over 2. And that is C. Okay, solve the square root of 2x minus 3 equals x. So in order to solve this problem, I need to get rid of the square root sign, and in order to do that, I'm going to square both sides. And when I square both sides, poof, be gone the square root. And now I'm going to bring everything over to the same side, so I get 0 on the left-hand side. I'm going to subtract the 2x. I'm going to add the 3, and now I have a quadratic that I can factor. And now when I solve this to find my zeros, if I set both of these equal to 0, I get x equals -3 and x equals +1. Now, notice that both of these are not an answer here. So now I have to go back and check my answers, because maybe one of these is an extraneous solution. So let's try -3. If I put -3 in here, I get -6 minus 3 is -9. Can I take the square root? I cannot. So -3 is an extraneous solution, and that's not going to work. So x equals 1. Okay, 40 says, consider the square below, x minus 3 units. What is the value of x if the area of the square is 126? So we know area is 126.5625. An area of the square means that x minus 3 times x minus 3 has to equal 126.5625. So let's distribute this out. We have x squared minus 6x plus 9 equals 126.5625. And now if we subtract that over, this is going to be kind of messy. If we subtract this over, we're going to get x squared minus 6x minus 100. Got to grab my calculator real fast. 9 minus 126.5625. 117.5625 equals 0. Now, I don't know about you, but I don't think I want to factor that out. So, what is another method that we could do to approach this problem? If I know that this has to be squared, because this finding area, this is also going to be the same side, and I know I have these answer choices, I could put in these values for x, and I could see which one works. So I could try 8.25 minus 3 quantity squared. I could try 11.25 minus 3 quantity squared. I could try 14.25 minus 3 quantity squared. And I could try 17.25 minus 3 quantity squared. So if this was a similar type question on an SAT, this is the method I would try, because this gets really messy when you're trying to factor. All right, 41 says the graph of which function has x-intercepts at -4, 0, and 7, 0. So you're trying to solve each of these for 0, okay? So I'm going to set x minus 4 equal to 0, x plus 7 equal to 0. This one gives me x equals 4. This one gives me x equals -7, so that's not it. I do the same thing for the next one. X plus 4 equals 0. X minus 7 equals 0. This one gives me x equals -4. This one gives me x equals 7. So B is your answer. Anytime they're looking for x-intercepts, you are solving these equations for x. 42 says, what are the zeros of the function? Zeros and x-intercepts are the same thing. So what we want to do is we want to factor this, and we want to set it equal to 0. So this time we're looking for the two numbers that multiply together to give me -20, that add together to give me a -1. So if I come over here, I'm looking for numbers that multiply together to give me -20. So -1 and 20, -2 and 10, -4 and 5. And remember, I can switch those pairs, but I'm looking for the ones that equal -1. So that doesn't, this will if I make the 5 negative and the 4 positive. So 5 negative, 4 positive. So now I want the zeros. So this is where I have to take each one of these and set it equal to 0. So this equals 5 and this equals a -4. So +5 and -4. All right, and 43 says, what are the x-intercepts of the graph y equals 2x squared plus x minus 10? Again, same concept we've been doing. We're going to factor, set equal to 0, and then solve. So 2x squared, so we've got 2x and x, and we're looking for factors of -10, so -1 and 10, -2 and 5, but this time it's going to matter where we put my -2 and 5 or -1 and 10 up here in these positions, because these two numbers and these two numbers have to multiply together and add up to be a +1. So this one's going to be a -2, and this one's going to be a +5, because these two multiply together to be a -4, these two multiply together to be a +5, and these two add up to be a +1. So this is a -4x, this is a +5x, and a -4x plus 5x equal 1x, which is what my middle term is. Okay, so now I have to find 2x plus 5 equals 0, and x minus 2 equals 0. So I subtract 5, so 2x equals -5, or x equals -5 over 2, which is -2.5. So that's one of my answers. And that looks like it's going to be right there. And here x equals 2. Okay, that wraps up remediation 5.